Cheers, Gauthier. Hey, everyone. I'm Camille. I'm the CTO of Watergenics. My path into machine learning started about 7 years ago. I actually used to be into physics, and I was too scared to do a PhD. Academia sounded terrifying, so I went into data science instead. 7 years after, I'm a machine learning engineer, and I've been a teacher in machine learning as well. And the idea for this presentation actually came from a conversation with Gauthier here. We thought that there was a bit of a paradox, which is that most people in our friend group or like social circle have some kind of interest in AI and machine learning. Like they've probably heard of like self-driving cars or like deep fakes or some cool stuff, right? And yet they seem to have very little actual concrete idea of what it's like to work in the field, right? It kind of feels like magic. Let me actually share my screen so we can start the presentation. So this is what usually happens when I introduce myself to someone. If I say that I'm a programmer, their reaction is like, cool story. Probably you're working with nerdy laptop things all day. If I say I'm a ML engineer, it's like, whoa. It's like, yo, do you talk to robots and stuff? Like, do you, some kind of ex machina situation where you're kind of training this female robot or something, right? And this is kind of weird to me because there shouldn't be that much confusion. It's also a bit of a frustrating misconception, because I think when you have hype and confusion, that's when people feel a bit scared. There's a bit of a barrier of entry, right? And maybe some of these friends might want to get into data science, but feel a bit scared because it feels like magic or something. So the presentation today is me going through my top actual real reasons why being in data science is awesome. But before we get into that, we actually need to kill the hype. And I first want to talk about why machine learning is nothing special, right? That'll be the first part. Then we'll get into the more fun stuff. So to get started, this is maybe one of the most important points that I want to make. Machine learning is just a tool, right? And by tool, I mean a device, something, in this case, software that does a particular function, right? No magic, no fanciness. Let's pick an example to explain what I mean here. Let's say that I'm a fan of beer. Now, this is not that much of a hypothetical scenario, but let's say I'm a big fan of beer and that my favorite beer is Corona, right? Now, I'm also a nerd and I like to follow things online, right, on Twitter. And it's been a little bit hard lately to follow #Corona on Twitter because there seems to be random stuff going on about some kind of, I don't know, like virus or something, right? So I want to make a tweet filter that filters for stuff about Corona, the beer, right? So for a given tweet, like chilling on the beach, please bring a beer, #Corona, I would like to build software, a tool that can tell me if this is actually about beer or if it's about this pandemic stuff. Now, for the coders amongst you, we can make this very simple. We can check if the word beer is in the tweet. If it is, it's probably about Corona the beer. If not, probably not about that, right? And I've instantly made a tweet filter for this theme. I've made a tool that accomplishes a particular function or a task. And here's the point. This tool can be as simple as this if statement, or it can be as complex as a deep neural network, right? So I can also do the same function with something super complex, but it's still a tool. It's the same idea, nothing more, right? Now, of course, this is not usually how it's portrayed in the media, because that's not as exciting or sensational. So this is how most AI engineers and researchers feel about the whole AI apocalypse stuff, when actually we just use it as another software tool. So the next part of this is that just like tools, just like regular software tools, they have to be correctly configured, right? You can do things badly. So if we go back to our example of a beer tweet filter, this is a pretty bad tweet filter, this if statement, not gonna lie. If we get a statement like this, oh, the horror, I can't even taste my beer, hashtag Corona, which is pretty clearly about the pandemic. Well, this is gonna erroneously tell me that it's about beer, right? So this is a wrong answer. And the point I'm making here is that the same thing happens with machine learning models. They can also be built bad and wrong, and they can also give wrong answers because they're just a tool, right? All right, so let's dig a bit deeper, because a tool is nice in general, but what type of tool is machine learning? Is a statistical tool. It's just statistics. Machine learning tools come in the form of models. That's how we call them. Models are this kind of abstraction that transforms data. This sounds very vague, but in the previous example, the tweet was data in and the answer was data out, right? We've just transformed a bunch of random data into useful data. Machine learning is just transforming data, nothing more special. Now, these models, they are statistical learning models, meaning that instead of telling it explicitly how to filter for beer stuff, I'm just gonna let it learn from examples, right? And there's a side effect from this, which is often they're called black boxes, meaning I'm not actually sure how it learns this, but it figured it out. So if we go back to our example, what does this look like? An example would be a tweet and a result that I want to get from this tweet, right? So in this case, the original tweet and the fact that it is indeed about beer. And if I have many of these examples, I have a data set, and my machine learning model here on the right is currently empty. It is dumb, it does nothing. And I can train it through a procedure called optimization, right? So I'm gonna let it figure out how to map these tweets to these results that I wish to see. Again, this is purely statistical. There is no magic, there is no crazy things going on. It's just statistical optimization. It just sounds a bit more fancy because, you know, it's about words and in this case, beer and Corona. And then once I've optimized my model, I can give it a random tweet, like, would he be texting me if he wasn't trapped inside? Hashtag Corona. And this model has now learned how to interpret words and map it to result. And in this case, it has learned that it is indeed about the pandemic. And what I meant by black box is that if we look inside of this model, well, it's not too clear why or how it does this mapping. It's not always clear, let's put it that way. But that's just because humans don't talk statistics. The model learned it in a specific way. It learns weights and numbers and stuff, but we're very bad at interpreting them. So we don't speak statistics very well. So why is this relevant? Optimization doesn't mean understanding, right? This toy model that we talked about, it doesn't understand anything about Corona or beers or language or anything. It has just mapped things that we showed it, and it does that very well. And black box models, they're not magic. It's not because you can't look inside that they do crazy things beyond, you know, what is imaginable. And maybe it has learned something more about the world. No. It's just that we don't talk statistics very well. So it's just numbers. That's what it means. All right, so yeah, that might be disappointing to you, maybe obvious to some of you as well. This is kind of how I feel about machine learning. It's just a statistical tool, but it's much more fun to call it machine learning and AI because, you know, it feels better. But yeah, that's the reality. So one consequence of it being a statistical learning model is that its behavior depends a lot on the inputs that we feed it, right? So this is usually called garbage in, garbage out. It means that if your data set is bad, well, it's going to make mistakes. And the reason why this is important is because most data sets currently that you can find are biased by default. They're going to not represent reality in a perfect way, or they're going to have mistakes, or they're going to have lots of artifacts, right? So most machine learning models are going to be biased in some way. But again, this isn't because the machine learning model is evil and tries to discriminate. It's because if you feed it things that are biased, it's going to make those kind of decisions. Models, in other words, are pretty dumb. They just follow what we show them, not what we intend them to do. This is obvious in a classic controversial example from last year. This is the model called Pulse that does upsampling for faces. It is very cool, by the way, in terms of the technology. So if you give it a pixelated face like this, it can figure out through a GAN model how to optimize a upsampled, meaning high definition face that matches this pixelation, right? So the input is on the bottom left-hand side, and you end up with this big image. It's literally the, enhanced super resolution from all these American crime series and stuff, right? Which is nuts. It's super impressive. However, this was controversial last year because someone tried to feed it the pixelated image of Obama, and this is what the model came up with: a white man, which is a little bit problematic. Indeed, the model hasn't really learned how to be very fair and represent humanity in all of its beautiful colors. And it got a lot of controversy because, like, who's to blame? Is the model, the creator, the whatever? The explanation behind this is the data set that was used for this model, Flick Faces HQ, mostly has pictures of white people. So this is what you end up with. The models are dumb, garbage in, garbage out. It's a good example. Which leads us to the next point, because there are people behind the selection of data sets and the engineering of these models. And machine learning doesn't have a life of its own. It is only as good as its engineers and creators, right? Machine learning engineering takes into account the selection of the data sets used to train the models. It also takes into account how to test those models. You got to verify that it's doing what you want it to do. And then you got to monitor them to make sure they're still doing what you expect them to do in the first place. Here are some examples of when the creators, made some mistakes, because of course this can be done badly. A classic one is Amazon's job hiring. So they made a text model that could read CVs and filter out job applications to make the process easier. This was very problematic because turns out that the system learned that male candidates were just preferable. Now, this is, again, an example of garbage in, garbage out. Turns out this was trained on historical data, which of course contained biases because STEM fields and tech roles in Amazon are mostly held by males, which doesn't mean that this is a desirable outcome, right? For me, this is a classic example. I mean, this also was controversial. I got a bit of it's just bad engineering for me, right? The function was to be filtering for jobs that should be fair. This was done in an unfair way. Yeah, the models are dumb. A third aspect of this is that beyond the engineers is also the people who choose where to apply, right, the machine learning models. So machine learning is only as good as the application itself. Building software products is a complex process where with a lot of people behind it, you got to actually design and conceive products and implement them with machine learning. And all product engineering requires technological ethics, right? From the email, through blockchain, through websites, through anything, you got to think when you create a product, what can this be used for? Who is it going to be used by? And is it for good or evil, right? This, of course, applies to machine learning as well, and it can be done pretty badly. I'll give you an example. and this is one of my favorites, Tai, the Twitter chatbot from Microsoft. Microsoft released a chatbot on Twitter. It was like, yeah, it's this conversational AI. It's going to speak to people. It's going to interact. It's going to learn plenty of stuff. And it did, right? At the start, it was trying to learn about people and stuff. I think within 24 hours, it became an absolute disaster, a sexist, racist bot that would insult everyone that would talk to it. Quite entertaining and not so harmful in this case, but a good example of when the application is premature compared to the technology, right? You can blame Tay. I think that's not the right way to see it. I blame the people who thought that this would work out well when the technology was maybe not so ready and not verified, right? Not tested correctly. But there are examples of bad applications that are much more harmful and problematic. An example is a paper that was submitted, then retracted by the publisher at some point in 2018, I think, where this research group claimed to do crime prediction by facial recognition, meaning they can recognize the likelihood of you committing a crime based on your face, quote, in an unbiased way. Again, you can blame the power of AI here, or you can blame the people trying to apply this tool for this application, which is, by the way, a terrible idea. All right, so we've gone through a lot of reasons why machine learning is not special, no need to have some hype, chill out, it's just yet another software technology. But that's not the exciting parts, right? Let's be honest. I am very fond of the field. I get very excited about it. And I want to tell you all of the best parts about working in machine learning and AI and why it is indeed very special. So my top reason why machine learning is special is that it is deeply cross-functional. And this is something that is not often understood from the outside. We're not all math nerds behind computers, partly, but not always. To make machine learning work, you need some computer science understanding, you need some statistics, and you need some engineering. This is pretty clear, right? Although that's already pretty cross-functional compared to typical roles. But what's less understood is to make it work properly, you also need some product experience, you need some design, and you need some good communication. A data scientist, for example, is all about communicating data analysis and insights to the people who care about this, right? Typically business executives or business stakeholders. Now, this is at least half of the job and is a complete different set of skills from your regular coding. And even more surprising, or it was for me at least, you will require a healthy dose of subject matter expertise, right? Depending on what this tool, right, is applied for, you will have to learn the field in which it's applied. I'll give a personal example. I founded a company about 6 months ago called Watergenics in the field of water quality monitoring. And trust me, I have learned more about shrimp farming in the last 6 months than ever in my life before. I have a lot of shrimp facts. And this is not because I'm trying to be a shrimp farmer. It's just because if you're going to do AI products for this field, you need to understand the problems and you need to design products, right? So I find this very special because it's particularly enriching. You're going to work in cross-functional teams with people from different backgrounds and you're going to create things together. And it's a lot of fun. All right, so moving on. The next reason why machine learning is special is that it's a real teamwork effort. There's some misconceptions around lots of different terms that are being thrown around. Data scientist, machine learning researcher, machine learning engineer, AI, it all gets thrown into a big bag and it's like, oh, what does that mean? So I've made a table for you so we can clarify this once and for all. There are many roles that touch machine learning. A machine learning researcher is someone that tries to push the limits of knowledge in the field, right? So they will research new algorithms. And their main KPI, their main goal when they get to work in the morning is to create new papers, right? To publish new science in the field. Typically, they work with academic data sets, and they're not too worried about things working in real life. They just want to prove new algorithms that work. A data scientist is someone whose purpose is to create insights. It will be someone who goes into a company's database. They have a lot of data about lots of stuff. They don't know really what to do with it. And the data scientist is the superhero that comes in and like cleans things and finds things and extracts valuable information that have an actual business effect. They typically use existing algorithms on real data sets. And finally, a machine learning engineer also works with machine learning, of course, but creates products, right? This is going to be things that are run in regular software. Examples are like Google Translate or autocomplete or some of your Instagram filters. These are not insights. These are actual software products, and there are people building them. These people are machine learning engineers. So the idea here is that all of this is teamwork. Typically, a company will have a lot of the spectrum hired, and there's actually even many more. There's this classic diagram called the data science hierarchy of needs that doesn't get old. It just gets better every year the more you look at it. That really explains the sequence of events and processes that need to be done in order to create successful machine learning products. And the list is vast. There's a lot of things that need to be done. And in each of these steps, there'll be more or less specific roles in the world of machine learning, trying to make the pyramid hold up. So the takeaway here is that you don't just get into machine learning. There are many different roles, and there's probably one for you. All the way from like writing data pipelines and working deep in databases, all the way to being a data viz expert / translator for some super business people and really translating in graphs and stuff. There's probably something that you'll enjoy. All right, so machine learning is deeply experimental in nature. This comes from the fact that you can know as much machine learning theory as you wish. You can be a statistical don, but at the end of the day, accuracies are unpredictable and models have to be tested. Again, because it relies on the data sets that we're trained in, right? So you can't just take something out of academia, get it, put it in production and expect it to work the same. So you have to test things. And this means that always you develop models empirically and incrementally. You try things that are simple, you see if they work well, then you try more things and you experiment more. It's exactly like research in science, right? And this is super fun. This is one of the best parts of working in the field. It's super exciting, right? It feels like you're doing this with some crazy solutions and seeing the results and, oh, it worked, oh, it didn't work, all this kind of stuff. This is a classic XKCD that captures this feeling. Sometimes, no matter how much you know about the theory, it feels like you're kind of just twirling a big bunch of numbers until something happens correctly. And again, this is quite fun. But beyond the fun aspect, this is actually quite significant. Andrej Karpathy, who's a famous and prolific machine learning researcher, claims that this is actually the start of a new software paradigm that he calls software 2.0. So what he means by this is that we're moving away from coders explicitly writing instructions. So if contains beer, then it's a beer tweet or it's a virus kind of thing. So we're not writing explicit instructions anymore. We're writing instructions so that algorithms can learn their own, right? It's kind of like a meta thing. So the core skills are less writing the instructions themselves, but more managing experiments, managing all these attempts at optimization and validating and testing, way more close to scientific research, right? Yeah, I gave a bit of an idea of a workflow here to illustrate this. A classic software engineer is like, okay, we have a problem. I'm going to design a solution for this problem. I've designed the optimal solution. Now I'm going to implement it, right? And the typical thing is like, there'll be a manager somewhere asking, okay, how much time, how many people do you need, how much money, and it's like, okay, I need 6 weeks, I need a team of 4, and I need some AWS credits. Cool. And then the machine learning engineer, they're going to assess the problem first. Then they're going to design experiments so that they can find a solution. Then they implement the experiments. If the experiments were successful, which they're usually not, then you have to go back and start again. Then they can design a solution, and then they can implement the solution, which in the manager example, the manager asks you, okay, how long do you need? How many people? How much money? And it's like, I need 6 months. I need 200,000 euros worth of GPUs. I need a team of 5. And then I can maybe tell you if it's possible, which is quite a different way of working. All right, so machine learning is imperfect. And I'll tell you why this is a good thing in a second. So systems that cannot be debugged need better testing. If I can't go into my code to find out what was wrong, I better make sure that it was right in the first place. And systems that are unpredictable, right, as we've explained before, they need better ethics because the consequences of their mistakes are greater. So I'll give a concrete example of this. And by the way, those things play into each other, right? Like if you can't debug it and you can't predict when it's going to go wrong, it really, there's some synergy, some evil synergy in this. So a concrete example is, a bug before machine learning or without machine learning is, oh, my app froze, my app is slow, my app, returned the wrong image or something. Bugs with machine learning applications are more like, oh, my app told me to kill myself. This is an issue. By the way, this is an actual example from a chatbot that was trying to do healthcare support for like assisting psychologists and stuff. So giving like support, and genuinely it started telling people very wrong things. So it's a bit dark, but keep in mind, this is to illustrate how bad those bugs can be and how unpredictable they are. And the result of this is that there are new roles for these new challenges. The machine learning ecosystem is growing and blooming with a whole bunch of new things around testing. So machine learning QAs, machine learning operations, machine learning security, AI ethics. There's, every big tech company is getting an AI ethics board to ensure all of this. And this is very exciting. It's like this field is maturing and growing as we go. And I think that's pretty cool. All right. Machine learning is also creative in unexpected ways. So, and this is in terms of day-to-day, this is one of the most fun parts. If you want to build an effective machine learning model today, you still require to do some kind of innovation, right? There are so many unsolved problems. And as an engineer, this is what we're really about, right? Typically, I'd say that in software engineering or in older fields, the innovations turn around maybe performance or speed or stuff that are non-functional. But in machine learning, if you want to get the thing to work correctly, you're going to have to be smart and be creative, or it's not going to do what you expect it to. So I explain this with I'm going to channel my inner XKCD here and try to make an insightful graph. So if we have the maturity of a field on the x-axis and the potential for innovation as an engineer on the y-axis, I think things typically look like this. At the very birth, things aren't very thought out. We don't even know the problems to solve. There's little room for innovation apart from the first core little advances. Then there's an absolute boom where it's like, whoa, like we can do all this stuff, and there's all these problems to solve, right? And then slowly it kind of goes down, and there's some little bumps when there's some surprises, like, oh, there's this new problem we didn't think about before. And then it kind of fizzles out, where it becomes much more about implementation and a lot less about research or, experimental development. I'd say machine learning is around here. I keep thinking year on year, okay, now this was it. This was the best year for machine learning ever. Like all this crazy stuff happened. And every year I'm proven wrong. So there's so much creativity and innovation to be left to do. And there's another effect, which is, I think as a field gets more mature, there's more and more opportunities in niches, in a kind of nichification process, right? What I mean by that is, okay, maybe if you get into data science today, you're not going to solve the big problems of like computer vision and self-driving cars and stuff like that. I mean, I hope that maybe you will, but it's a bit more challenging. It's a bit more down on the slope. But there's so many niche problems out there. Like the more niche, the better, actually. Maybe I'm an example of that. Shrimp farming is pretty damn niche. And all these problems, they require or they can be helped with machine learning solutions. And you can be creative to really cater to those particular issues and find some creative ways around it. And that's a lot of fun, right? Innovation is challenging. It's exactly what we're after as engineers, and is definitely still true in machine learning. So there's another way in which machine learning is creative. We're getting into the more abstract reasons why I'm excited about machine learning. I don't know if you noticed, but so this is a bit more higher level. But the place of humans in the machine learning engineering loop is also evolving with time. So what I mean by that is, once upon a time, a machine learning engineer, a data scientist, would focus on models, right? It's like, what algorithms can I make or use in order to make this better, right? So you're playing with algorithms and you're trying different variants or whatever. And that worked well once upon a time. And it's kind of being phased out by actually working on your data sets more. This might sound a bit vague, but it makes a huge difference on your day-to-day, right? Am I actually changing algorithms, or am I optimizing data sets so that the algorithms work out well? And I can tell you, in the last 2 years, enormous shift. Andrew Nguyen has a very popular recent chat about this. I linked it down there, super interesting, where it completely changes the way you're doing your job day to day, right? And there's really promising signs that this might change even more in the future. I don't know if you've heard or played with GPT-3 and all the big text language models that are amazing and do lots of cool stuff. One of the biggest paradigm shifts around those models is that they're so big and they know so much that actually it's the way in which you probe them that kind of determines their performance. And so there's, again, another shift into what a machine learning engineer is supposed to do, where I'm not going to look at the model itself. That's just a given. I'm not going to look at the data set used to train it. That's enormous. It's like the whole of the internet. But instead, I'm going to see in what ways I can poke it so that it's productive, right? I'm kind of like trying to get it to give right answers. And again, that's a huge change in your day-to-day. It means that what I did 3 years ago as an engineer is different from today. And what I will do in 3 years is probably going to be different from today. I find that very exciting, and it keeps you, certainly isn't boring, at least. Okay, so one of the best things about the field of machine learning is how open it is. And by open, I mean, of course, open source. But because machine learning is pretty cross-functional, as we saw before, I also mean open source research, like academic research. I mean open source data, like data sets being shared with the world. I mean open source code, of course. And I mean open source models, right? These models that can get pretty big, by the way, and pretty expensive to train, are very often shared for free, just on these repositories for everyone to use. This is amazing because, well, first of all, it fits into the, I'm not going to tell you why open source philosophy is so important and valuable in any field, but it also makes your day-to-day much easier. It's like you can reuse and share all this stuff with people across the world. I'll give you examples of this or numbers. Archive is the famous repository for sharing academic papers. Last month, there were 3,500 machine learning papers released, only in 1 month on Archive. This is completely open research, right? This is people being like, I've discovered a thing, here it is, take that and go further with it. In fact, today, at the time I checked, which was like an hour ago, there were 78 papers. This is jumps in science, right? That's a lot. That's a lot of jumps shared openly with the world, which makes me really happy to think about. And another example of this is the amazing GitHub repository called Transformers from Hugging Face. So Hugging Face started as this chatbot, small company kind of thing. In fact, they are based in Berlin. And they decided to open source and release a repository of all of the biggest models in text machine learning. This was, I believe, 2016, maybe. And 5 years later, they've just raised $40 million for a Series B. And their GitHub repo has, more importantly, their GitHub repo has 40,000 stars, which, you know, are just metrics, but it shows that the engagement and the value of sharing and collaborating on these topics in machine learning is huge. And it makes machine learning development fast. If you want my top reason why behind the AI revolution, I know people talk a lot about hardware and stuff, which is also true, but open source culture has to be one of the top ones. Which is what I'm saying here. The machine learning field really has grown as a collaborative effort between all the big tech giants and also all the smaller researchers. And this is really what's driven its progress in the last few years and its explosion. And why is this also nice? Well, it's nice to contribute. It's a really nice feeling and it's rewarding. You know, you have all these amazing repos that are open and you can, you know, find a bug, you know what, find a spelling mistake in a comment and feel like you've contributed to the state of machine learning and you've made the world a better place. All right, so I know I've spoken a lot. We're getting slowly towards the end. I'm sorry, there are many reasons why machine learning is great. So I like machine learning because it's very fast. In fact, it's blazingly fast. It's mind-blowing sometimes how fast it goes. The progress is a question of, well, it used to be a question of years-ish, like a year. Lately, it's been of months, and nowadays it feels like weeks. It feels like if you don't keep up from a few weeks ago, you're going to be left behind. I'll give you an example of this. Let's look at the most classic problem in machine learning, which is image classification. This is the, you know, this is a cat. This is not a cat. You know, this is or for Silicon Valley fans, this is a hot dog. This is not a hot dog. And if you look at the state of the art, I hope you're seeing my screen now. So this is the state of the art on the most popular task in machine learning. If you look back in 2011, which feels like, you know, ancient, but it's only 10 years ago. Come on, it's not like, you know, we were around 50% accuracy. And there's two things, well, there's several things to notice here. First of all, every single green dot is a improvement in the state of the art, right? So this means like this is the best model out there that does the best machine learning. There's a lot of green dots. They're very regular, right? And you can even see these huge jumps, right? There's some clear, massive advances. This is pretty rare in the field of science. Usually it's a question of like, you know, little incremental things. Here, there's research papers that, you know, divide the error rate by 10 and like come over and just take over everything. And you can also notice towards the end here, the density of research is nuts. How many people are trying to beat this, the state of the art is incredible. And I didn't make this on purpose. The latest, best model for image classification is from a mere few months ago. This is how fast it moves. And this is the case with most tasks. If you want to be on top of your field, you have to read all of the latest stuff. Now, that can sound like a negative, because it sounds like, whoa, that's pretty overwhelming. That sounds like a lot of effort, right? But I think not. I think it means that you're always working on the latest and the bestest. And having this combined with an open source culture is really awesome. Because from one day you're working on one model, the next you're working on this thing that Google just released like 2 weeks ago, and this is what you're developing. It's like, wow. Another reason why machine learning is so damn fast is, of course, the hardware developments. So everyone likes to talk about Moore's law and like all these processor sizes and stuff. Another way of looking at processing power is actually not about the number of transistors that you can get on a chip, but actually the number of operations that you can do per time, right? So petaflops per seconds. And if you look on this graph, which shows all of the biggest machine learning models and the amount of computation that they take to train, we are clearly speeding up. Like, it's insane. So the sizes and the immensity of the latest models, and this has actually not been updated since 2020, so it's off the chart by now, is incredible, and it's moving faster. And again, working with cutting edge tech that moves super fast and is open source is pretty damn cool. All right, so there's another aspect to this, which is kind of surprising or kind of different, which is you need fast learning skills to thrive in the field of machine learning and AI. Deep expertise of a subject acquired across 20 years of research and stuff is not really as valued as just being able to adapt and learn and read and apply very fast, right? Again, this can sound a bit overwhelming, but I see it as a really nice level playing field. It means that there's new players all the time coming in. It means that people can start data science and machine learning like a year prior and then get straight to the best and the latest and work with the state of the art and already be on par with everyone else. It's a bit it's super exciting in that way. All right, last 2 points, I promise. Machine learning is very impactful. So this is a bit more obvious, perhaps. Everyone's heard of cool machine learning applications and stuff. But the important part here is that it has power for both good and bad. That's the point I'm trying to make. I'll give you a few examples of this. Machine learning is notoriously being used currently by the Chinese government to do racial profiling of the Uyghur population. It all started about 2 years ago, I think it was 2018, wherein a paper called Face Recognition for Racial Profiling got published by a Chinese research institute. And surprise, surprise, 2 years later, there were media reports of this being used on a massive scale to, literally be able to know what ethnicity is where in the country. Pretty awful and a clear, really bad application of machine learning. But the point here is the impact, right? The magnitude of the effect of this technology and the power that it holds. A bit of a contrasting example, AI for Good started as a global summit organized by the United Nations to kind of get thoughts and engineers and people together to try to solve societal and environmental problems with AI. It's become a bit of a movement, a bit of there's a hashtag AI for Good. There are massive tech companies that are dedicating entire pro bono teams, a bit like the pro bono lawyer kind of setup, that strictly work for free on problems related to NGOs and stuff like that. It's a real movement that has taken momentum and already doing a lot of impact and a lot of good in the world. So on both sides, machine learning has a lot of power, and this is very motivating as an engineer, right? Like working on things that actually have an effect is a really rewarding aspect of the work. Another aspect of how impactful machine learning is a bit more subtle and surprising. Machine learning is really modifying, I said it was just a tool and it just transforms data, like, sure. But the way in which it can transform data is completely changing the paradigm of automation. And this, yes, might happen in more obvious ways, like taking away jobs and stuff like that, but also in more subtle ways. My favorite example is AI for arts, right? So there's all these super talented artists that are mixing AI in a creative way to really redefine what it means to create art, right? Because what the place that we previously had as data transformators is now taken half by these AIs that do the processing. So this is Quasimodo, or Mario Klingemann, who makes these beautiful paintings that are made by taking a neural network, a computer vision model, and making it forget. So it's a model trained on facial recognition, and you're selectively trying to make it forget things about faces. And he calls this series neural decay. It's very Bacon-esque, and it's I think it's wonderful, super nice visual effect. There are many artists doing clever things with AI. Another example is in music. Holly Herndon released Proto a few years ago now, in 2018, I think, where she used machine learning models to help her with composition. So part of the actual sheet music was written and composed by these AIs, which is super cool. And another surprising way in which AI really changes and has a big impact beyond its applications. All right, last one, and one of my favorite ones. Machine learning is enlightening. And what I mean by this is it's helping humanity push the frontiers of knowledge. It does this in very direct ways, right? There are many applications in science for machine learning models. A very powerful recent example is AlphaFold. In fact, AlphaFold 2 by Google researchers, which has, I'm not going to say solved, but made significant advances in an age-old problem of predicting the folding of proteins, right? So a big problem in biochemistry is understanding how on earth does this happen. It's very complex systems. And what you can see here on the right is that the model, given a sequence of protein, can predict literally its folding and therefore its function, which is immensely helpful in healthcare and in biomedical science and biotechnology. So clearly machine learning can help push the frontiers of science, and it can do so in even more of a subtle way, which is there are rare occasions where the machine learning field has actually taught us about the science in which it's applied. I have quite a lot of experience or most of my experience comes from the world of natural language processing, so big text models. And this is very clear in that field. Computational linguistics is a pretty mature field and pretty old. In fact, linguistics is age old. There's always been debates, philosophical debates around linguistics. Noam Chomsky, for example, might ring a bell to some of you, around the semantics of words and what defines words and their relationship to the real world, right? So like if I call an apple, do I need to understand what an apple is in order to be able to do things with these words? Well, turns out that the progress in machine learning in natural language processing around 2015 comes in and completely blows out of the water many theories around linguistics, notably something called the distributional hypothesis, which means that you can in fact learn a lot about the meaning of a word just by its neighbors. So a model can understand language pretty damn well just by reading a lot of text and inferring meaning from neighborhoods without ever seeing anything about the world, right? Which is significant in linguistics. And another one, which is the lingua franca. You might have heard this. It's kind of an age-old concept of, languages are just different facets of this core information dense language. Maybe there's a common thread to all of these other human languages as a bit of a philosophical gold fleece, right? A holy grail. Well, it turns out that Facebook in 2017, I think, developed embeddings called Muse that are multilingual, where, to put it simply, literally, they can align semantic spaces of different languages and just plot them together in this kind of like multilingual representation of words, which is mind-blowing and super significant in linguistics. There's a lot of writings about it and stuff like that. And I find that amazing. It's like, we're learning through the thing and the thing is helping us learn. It is particularly inspiring. All right, so this is all my top reasons. Machine learning is cross-functional, it involves teamwork, it's experimental, it's also imperfect, so there's lots of stuff to do. It requires you to be creative, it has an open source culture, and it is fast, impactful, and also enlightening about the world around us. And if you find any of these reasons also as exciting as I do, turns out I'm also starting a course about data science in a few weeks. That is from scratch. The only requirement is to know some basics of coding, so beginner programming experience, where I will go through data science and give you foundations in machine learning. So maybe you have some questions, I hope so. And as a little PS, we're also, of course, hiring, so contact me if you're all about the shrimps. Yeah, are there any regulations or tools helping machine learning engineers to spot their own biases, or at least biases in their input data sets? Excellent question. And two different answers, because the former and the latter are quite different. So spotting biases in input data sets, yes. This is a super growing field. It's the whole meta field, right? It's like statistics to develop better data sets so we can do more statistics to build products. But there's a lot of things around that and model interpretability. I forgot the name now, but there's an actual GitHub package that literally does this, like analyzes biases in data sets. So the answer is yes. The other part, not so much. And it's a very active and controversial topic. So the place of the actual engineer in this, there's some great literature in this, which belongs to like ethics of AI, especially around the fact that the field itself is not very varied and not very diverse. So if you have a bunch of middle-aged white men making AI algorithms, is this how you end up with biases as well? So it's something to keep an eye on, and that definitely needs more work and more understanding about exactly where these biases are coming from. By the way, as an addendum, there's also another part, which is studying the biases in the algorithms themselves, because some algorithms kind of penalize for minorities by design because they try to make average answers. And there's also a lot of people, well, a growing amount of people looking at what effects that might have. Yeah, why are people with different backgrounds drawn to machine learning? Well, I mean, I came from physics and I was drawn to it. I think it's because it's emerging as an ubiquitous tool, right? The real core problem you're trying to solve is data analysis and getting insights from data. And in the age of big data, this data is everywhere. Any company you might work in probably sits on some data that could be used for something and isn't being used for that. I think that's part of the cross-functional, exciting aspect of machine learning is you end up with lots of people from different backgrounds. And in terms of pre-requirements, there's some learning to do, but because it goes fast and because there's kind of this hacker, fast learner mentality in the field, I'd say knowing basic programming skills gets you far enough. And then there's a lot of resources online to do so, either on your own or through courses, for example, the one we're starting in a few weeks.
So I have a similar question. So I'm jumping to this question, like what would be your best advice to start a career in machine learning?
I would say learn, I mean, depending on where you start from, learn basics of Python, get comfortable with that, because if you're starting from very, very, very scratch, a lot of your days will be playing with Python and coding, and some people don't like that, which is fine. But maybe you want to figure that out first before you dive straight in. And once you have why Python? That's because it's kind of the language of choice for the field. But it could be anyone, really. So like, familiar yourself with coding if you aren't familiar. And if that feels kind of okay and good, I would say start a course, get into it. Lots of resources online. And before you know it, you'll enjoy that very hands-on experimental approach, and you'll start trying models and data sets, and you'll get that, ooh, it works, it doesn't, kind of vibe.
Cool, thank you. And then another question, do you see machine learning getting less open source with tech giants getting more involved? Super interesting question.
That's great. Well, okay, that's a great question. So I don't know about tech giants being more involved, because quite frankly, they've always been immensely involved. And the tech giants we're thinking of have been huge proponents of open source from the start. Not just for like generous reasons. Arguably, it's because they understood that if everyone was working on the same thing in parallel, that was counterproductive, and instead it's better for everyone to work on the same thing together. And they were pretty confident that they could maintain a competitive edge because they were so huge and could do execution better. But that put aside, yes, there's a bit of a strange shift in the last year or year and a half. OpenAI is at the source of many controversies, ironically, OpenAI, because instead of open sourcing models, they've hid them behind APIs, and it's unclear exactly what their intentions are. But I'll give you an example of why I'm still not too worried about this. Even GPT-3 and OpenAI, which is one of the biggest models ever made, that they hid behind an API, a group of AI researchers called Eleuther AI worked for like 6 months as a kind of like against the establishment kind of thing, and literally retrained from scratch their entire results and open source the model that they were hiding as a kind of like, well, okay, you're not going to do it, we're going to do it for you. And there's a lot of communities based around that are moving towards them. So I feel like, I hope the culture is entrenched enough that there's a bit of a resistance towards those tech giants moving away from open source, and hopefully it keeps going in the right direction.
So maybe we can jump to the next question about GDPR impacts.
How does GDPR impact machine learning projects? Amazing question. So it makes things harder, but better, I would say. Hard in some ways, but easier in some. So really having a privacy and data-centric design in your organization data storage, it can be a bit challenging in terms of accessing the data and stuff, because you can't just go in the database, copy stuff, and just don't worry about it and leave it on your laptop. On the other hand, it really puts an effort that is required, that is necessary for all companies to think of this first, centralize the access, control the access, give it to the people who need, right? And typically, in my experience, that's actually put less of that responsibility on the data scientist. Like historically, you're the person who wants the data, you deal with that. Like, go get it, go find that in the mess, right? Now it's much more common that you'll have some people dedicated to organizing this properly so that they don't get like a fine. And so in some ways, it's actually a bit nicer. Yeah.
What do you think about the GDPR in Germany? Because it's pretty strict.
Yeah, well, it's a European regulation, right? But Germany has some pretty strict privacy laws. I think it's super important. I'm pretty opinionated on this. The example I gave on the Chinese application of facial recognition for Uyghurs started with leaked data sets from Flickr of like a whole bunch of people's faces. And there's actually a website, maybe I'll find it, what's it called? Leaked.ai or something. There's a website you can go to check if your face was used to create these like evil machine learning models. Yeah, it's crazy.
That's so cool.
I'm terrifying. Right? It's like you might not even have an idea, but you're being used to do these kind of applications, and that's not okay. That's from the far west days of machine learning, where people exchange data over Google Drive. I think it's necessary to have stricter privacy laws.
So another question from Joel. Welcome.
Yes, how can one handle explainability of black box models? Well, I mean, that's a big question. It's an entire field of research. Arguably, it's, not got that far, but there are some methods. I actually saw a link being popped in here. There was SHAP values, right? Who posted this? Thomas, thanks for posting SHAP, which is an example of a method that can be used to kind of poke around and probe these models. Here's some more links. Yeah, lots of exciting research on this. It's still at its infancy, I would say. There's like a couple, like 2 or 3 useful methods you can find on GitHub to do so. But a lot more progress to be made. Right now, still in the industry, it's basically limiting the algorithms itself. So like, if you're working in a regulated industry, they're going to tell you, use logistic regression, don't use more fancy things, because we need to be able to track the decisions made. I hope that in the next couple of years, it becomes more normal to move past that, have bigger models, and have more guarantees around why they're making decisions.
And this is a very interesting question. I know it's really useful for his help. Do you think there is going to be a shift to faster programming language like C++ or Go for machine learning?
There is definitely there is a shift happening. C++ and Go are great examples. Rust, I know Rust is getting a lot of traction in machine learning in the Rust community. It's really hard to say right now, because there's also a shift in the other direction, which is platform and language agnostic model formats. So ONNX, like ONNX, is an example of that. So making model resources language agnostic, so you can actually develop in Python, do all the slow stuff, and then push that to a different environment without having to rewrite or develop in C++ in the first place. I think that field is super interesting and super cool. This is within ML ops kind of thing. And definitely people want to use faster inference engines for machine learning, but not necessarily faster for training and experimenting with. So I like the direction that it's going with, where you can do a bit of both and have best of both worlds. All right, Joel, as a data engineer, you would need to rewrite the whole Spark infrastructure to work outside of Java. Yeah, kind of. If you're stuck to Spark, of course. In my previous role, we were stuck in Java inference as well, and it was quite a headache to get like fancy state-of-the-art models working in Java, to be honest. But again, I mean, depending on your speed requirements and stuff, modern microservice architectures are kind of warming up to the patterns required by machine learning. So like, there's a lot more patterns where you'll have maybe your fast data processing pipelines in Java or whatever, and you'll have prediction endpoints with massive models that are super friggin' parallelized across like many GPUs, and maybe those are running in Python and super optimized or something else, right? So even polyglot environments are becoming more and more common to mitigate those effects.
Ernesto, do you want to use machine learning for your app soon, or what's your opinion about that?
Yeah, we've been thinking of transcribing the text for easier like classification of topics and stuff like that, but that's like for a year or something, not for now. And I actually like really a lot the subject, so I was curious. I have another question if no one else has. Do you think like quantum computing is going to have a bigger impact in how do you say, like near future?
Near future, well, how near is near, right? That's the $1,000,000 question.
Well, I think like 5-7 years, I don't know.
Yeah, if that's near, I think potentially. I would be very surprised before 5 years. Weirdly enough, this combines like, it goes back to my days in physics, and I never thought that this crossover would happen in my knowledge base, but it's super cool though, and so exciting. I know some people working on quantum algorithms for machine learning, right? Like optimizing them for that purpose. And I mean, it's such a game changer that it's impossible to imagine how it would affect the engineering field. Like I can't imagine how my job would be different if I had access to quantum computer. It's wild. But before 5 years, I'd be surprised. Hopefully, fingers crossed.
Thanks.
By the way, all the GitHub repos I mentioned and didn't name because of my terrible memory, I will add to the end of the presentation so that you can actually find them. So have a look if you're interested.
And if you appreciate this meetup and you want to join for the next one, feel free to join as well the meetup group, like that we will receive notification about the next meetup. And yeah, I'm showing a lot of links now. That's the last one for sure. But if you want to get more information about the live training with Camille, you can ask me here or directly by email with me. Thanks a lot for this. For this presentation. It was extremely cool, completely online. I will be extremely happy to do another one soon. And I would like to invite you for a beer right now. It's a bit main goal of meetups, but now it's completely online. Feel free to, yeah, if you're in Berlin, feel free to contact us. I would be super happy to meet you in Berlin. And yeah, if you have anything.
Cheers, thanks for listening.
Thanks, Camille. Amazing. Thank you, everyone.
Ciao, everyone. Beer.